position. Standard position is when we sketch angles called rotational angles on the Cartesian plane, the XY axis, with the initial arm where the angle starts at the positive X axis. You always start at the positive X axis, and then you either go counterclockwise if it's positive, or clockwise if it's negative. We didn't really do clockwise in grade 11. We did counterclockwise. We did all the positive angles, but now we're also going to incorporate negative angles too. So, positive rotational angle. What I always do first, and we're going to be adding radians right away here, so you guys have to be really good at degrees because we're going to convert to radians. Radians is just another measure of showing what a degree is like. So, this is 0. And then if I went positive rotational angle, I'm going to go counterclockwise. Okay? And then this is 90 degrees because it makes that little square. Then another 90 is 180. Then another 90 is 270. And then another 90 is 360. And in grade 11, we stopped there. We didn't go past 360. In grade 12, we can go infinitely. We can just keep going, both ways, positives and negatives. Okay? Now, say I give you theta equals 150 degrees. We always start on our x-axis. So I'm going to start at 0, 0. That's our rotational spot. This is like the middle of the clock where your hands are stuck, right? That's the middle of the clock. So, yeah, it just needs to be set to the right time, which it hasn't been, and it annoys them because it's loud. But I think it.
The test and I was so mad.
Okay. Then we want to go clockwise. So what I do is I go 180. 150 is how many away from 180? 30. So I'm going to go up 30. Remember, right in the middle is 45, correct? If we went right through the middle, because it's always 90, it'd be 45, and I want to go 30. So a little less than right down the middle, and I'm going to draw it like this. So I have one arrow this way. It's kind of like clock arms. But we always start on this x-axis, positive x. And then I'm going to arrow it like this, from this arm to this arm, because I'm going from this arm to this arm, 150 degrees. Now, negative rotational angles, it's the exact same like how we would find it out, but we're going to go clockwise. So we're going to go from like the positive x-axis this way instead. Okay? So this is clockwise. I always label my arms so that I actually go the right way. So it's the x-axis and the y-axis. Now, because it's a negative rotational angle, it still starts at 0 here, because we always start on the positive x-axis. But now we're going to go clockwise, and it's going to get us negative angles. So negative 90, negative 180, negative 270 is this arm, and then negative 360. And then we could keep going. Okay? Can anyone tell me what angle would be the exact same, where the arm would terminate on the exact same spot for the negative as this one? So what angle would I need in order for me to start here and actually terminate on this same arm? 210. Negative 210. Why?
Because you add 30 to 1, negative 30 to negative 180.
Yeah, you add negative 30 to negative 180 because we went this way and we said it was 30 away from this arm, right? So in order to terminate on the same one, it's going to have to be 30 away from this arm. That 30 away, correct? Well, how much does it take us to get here? Well, we went from here to here is 180, and then another 30 gets me negative 210. You're completely correct. So negative 210 is actually coterminal with 150, positive 150. Coterminal, which we're going to deal with in a little bit, coterminal means they terminate on the same arm. That angle terminates. Now, if I added another whole 360 to 150, what would I be at? 360 plus 150. 510. If I did 510, I would go around the whole 360, and then I would do another 150, and I'd terminate on the exact same arm. So as long as I terminate on that same arm, it's co-terminal. Now, what was the other way that I could quickly find this then? I could take this 150 and I could subtract 360 from it. 150 minus 360, if I have the whole 360 is this whole circle, right? And I subtract off 150, what am I left with? Negative 210. So that's how I get the other one too. Because it's literally just another 360 backwards to get there again. We'll be dealing with that in a little bit. The terminal arm is where the angle ends, and it can be in any quadrant or on any axis. So it could terminate, a 90-degree angle would start at the x-axis, but it would terminate on the 90-degree arm, right? So it can terminate on one of the axes, or it could terminate anywhere throughout. What angles correspond to each axis? We've already done that and labeled them above. So now we're going to sketch some angles. This is all review, everything we've done, except for negatives, right? But we're just adding a negative to it. It's not going to be ridiculous. Just go the opposite direction. So we're going to sketch 40. So before I sketch anything, you guys, I label my axis because that makes life so much easier. So this one is 0. This one is 90. This one's another 90, so 180. Then another 90, 270. Then another 90, 360. Where does 40 fall? Remember, our quadrants are like this. 1, 2, 3, 4. What quadrant does 40 fall in? 1. Now remember, straight up the middle is 45, right? If I went straight up the middle, it would be 45. So I start on here. I rotate among the 0, 0, right? And I don't want to go straight up the middle because that'd be 45. I want to be just a little bit less. And then you're going to label it from here to here as an arrow. So it's going to go like this, like a little arrow, and you're going to write 40 degrees. Because the angle could be on the outside of this as well, right? We did that last time. If we didn't label with an arrow, these both actually terminate on the exact same arm, but this one isn't 150 and this one's negative 210. That's why you have to label it with the arms and label the actual degree that's there, okay? Because this actually is the same as negative 320. Negative 320 would land me on that same arm. And I just draw the arrow this way. So that's why I have to draw the arrow in which direction I'm going and write what the angle is. Okay, 140. Oh, yay. First thing I do is label. 0, 90, 180, 270. I need my degree symbols. Bless you. 360. You need the degree symbols or it's not a degree, it'd be a radian. You don't even know what a radian is, so you really don't want it to be that right now. Okay? 140 falls in which quadrant? Second one. I like going from the x-axis as always. So 140 is how much less than 180? 40. So it's not going to be right up the middle. It's going to be a little more than right up the middle. You guys do negative 240 and 340, but negative 240, remember you have to label the axis 0, negative 90, negative 180, negative 270, negative 360. Try those out. Negative 240, you go 0, negative 90, negative 180, negative 270, negative 360. Still start on the x-axis, terminating or circling around 0, 0 to 240. And then 340, 0, 90, 180, 270, 360. It should have a degree symbol on it. We start here. 340 is 20 less than 360, so it'd be like this. Okay, Radian measure. This is where life changes forever. There are two ways to measure angles, degrees and radians. Radians are the favored way in Math 30-1. The method of measuring is tied to the circle as in stand position. Whenever we do any type of word problems and stuff, they're always in radian measure. Degree measure doesn't make sense in a word problem. An angle in radians is a ratio that compares two things, the length of the arc that's subtended across from an angle and the length of the radius. So we can rearrange this formula. The catch is, to convert from degrees to radians, you multiply by pi over 180. To convert from radians to degrees, you multiply by 180 over pi. The way I remember this is Dr. Pot. Degrees to radians, pi on top. So you're either going to multiply by pi over 180 or you're going to multiply by 180 over pi. If it's degrees, you have degrees and you're going to radians, pi on top. So you're going to multiply by pi over 180. And then radians to degrees, pi on bottom. RD Pob, some people memorize. I just remember that if for degrees to radians, pi's on top, then the other way, pi's on the bottom. I don't choose to memorize that one, but if you really want to, you can. When an angle is given in degrees, it must have the degree symbol, you guys. It has to have this degree symbol given immediately after it. When it's measured in radians, the angle either has rad after it or nothing at all. It can say rad, it can say radians, or it can say nothing. So when we had that 340 back there, I said it has to have that little degree symbol behind it, because if it didn't have the degree symbol behind it, we would assume it's radians. So you have to make sure that you use the degree symbol if it's degrees, because if you don't put a degree symbol, it's radians. And you'd be wrong then if you were supposed to give your answer in degrees, right? Alrighty. So, ooh, that's fuzzy. Convert from degrees to radians. So degrees to radians, pi on top. So I'm going to multiply by pi over 180 because pi is to be on top. They want us to give the answers in exact values in terms of pi. That means we can't put the pi in. The moment you put the pi in, you can't give an exact value. It's going to be a decimal because pi is a non-repeating, non-terminating decimal. The moment you multiply anything by a non-repeating, non-terminating decimal, your answer is going to be a non-repeating, non-terminating decimal. So we're going to go 270 times pi over 180. So we would end up having 270 pi over 180. The degree symbols would go away because it's radians now. Then we would have to reduce that. What could we reduce 270 by 180? What could we reduce it to? What could we take out of both of them? 90. If I take a 90 out of 270, I'm left with 3. The pi stays on the top over 2.
That's like 270 times 180.
Right. So 315 times pi over 180 gets me 315 pi over 180. What does that reduce to? Seven pi over 4. Now the question can be asked in a different way. Convert from degrees to radians, so same thing, but now it wants to the nearest tenth. So exact values means no decimals. Now it wants to the nearest tenth. So we're going to times by pi, divide by 180. So unless it wants it rounded to a tenth, you will always put in exact values, you guys. You're not going to ever round. And you're especially not going to ever round until the very last step in any math problem ever. It's like illegal. You should get a ticket. So if I want to the nearest tenth, I'm going to actually just put it into my calculator. I'm going to go 70 times pi divided by 180. And you get 1.2. And I could put rads behind it. I could put radians behind it, or I could just leave it. Like I left those ones, I didn't write anything behind them, they're radians. 205, so you're going to multiply by pi over 180. 3.6, 3.6. I could put radians behind it. Or like I said, I could have just left it as 3.6. Then it's radians as well, because if I don't write anything behind it, it's radians. Convert the following from radians to degrees. So degrees to radians, pi on top. So if we're going radians to degrees, we put the pi on the bottom. So we're going to multiply by 180 over pi. When you do this, when there is a pi on the top and a pi on the bottom like this, what's great about it is they cancel. So now you're just left with 180 divided by 4. Which gets you 45. But what do I have to remember to put behind this one? With radians, I could just leave them and not put anything behind the number. You have to have a degree symbol. Remember, your cum is on Tuesday, on the first 3 units. Negative 7 pi divided by 3. And I've posted cumulative reviews in Google Classroom, so you can go in there and do them as well. You can get 180 over pi. And the pi's will cancel again. And this time I'm going to do negative 7 times 180, except to the top, divided by 3. Negative 7 times 180 divided by 3. And you get negative 420 degrees. Now these next ones don't have pi's. So what happened is they converted it to this, right? They did a conversion at some point and rounded the decimal. They put the pi into it. So we're still going to do the same thing. Radians to degrees, pi on bottom. So we're going to multiply by 180 over pi. The only catch is the pi's don't cancel. So we're going to get a degree and a decimal. So that's why they gave us rounding. So we're going to go 1.57 over 1 technically. So it'll be 1.57 times 180 divided by pi. When you do it, you get 89.95, which is to the nearest tenth what? 89.95. 90.0. So 90.0 degrees. If you didn't put the decimal 0, people will say, well, it's the same number. It is, but it's not rounded to the nearest tenth, so you'd be wrong. It'd be rounded to the whole number. Negative 1.4. Negative 1.4 rad, so we're going radians to degrees, so pi on bottom. So times 180 divided by pi. And it equals negative 80.2 degrees. Arc length and stuff like that we're going to deal with tomorrow because we did the review of the test. So I'll give you just the homework on just that part up to there. We're going to look here. So page 175 of this. Odd letters are the letters that correspond with odd numbers. So A is the first letter. It will correspond with 1, which is an odd number. So A, C, E, like that. So start at A, skip 1, then do the next one. Don't overthink it.